Right, today we are going to practice adding and subtracting fractions. So first of all, on that fractions review paper, I want to just go over adding and subtracting fractions. Enjoy it at the beginning at least, because it gets harder when you throw polynomials in it. When you are adding and subtracting rational expressions that have polynomials in them, that is the most difficult of all fraction operations to do. So at first it might seem, oh my gosh, this isn't so bad, but when you start throwing polynomials into it, it gets a little bit cumbersome, but so yeah, you gotta just hang in there. First of all, number one, on this paper it says 1/3 plus 2/3. Notice, first of all, that the denominators are the same. They both have a denominator of 3. When you add fractions that have exactly the same denominator, the denominator stays the same. So it's going to stay at 3 on the bottom. So I'm going to stay at 3. And then all you need to do to the numerators is just add them together. What's 1 plus 2? 3. So we end up with 3 over 3. 3 over 3 reduces, though. What does 3 over 3 reduce to? 1. Reduces to 1. All right? Number 2, denominator's the same. We have 6's in the denominator, so it's going to stay a 6. And then the numerators we add together, 1 and 4, you get 5, so you have 5 over 6. 5 over 6, I do not believe reduces. All right? Finish up the last two quickly. I'm going to start talking about number 5 now. Why am I going to talk to you about number 5?
Because it's not equal.
Different denominators. The denominators are not the same, therefore we need to follow a different process. Now, when I was a student, years and years and years and years ago, I was not shown to add fractions with different denominators the way that I am going to show you right now. And the reason I'm not going to show it to you is because a students, I should say, a long time ago showed me a shortcut, so to speak, to adding together fractions that didn't have the same denominator. And I liked it, and I had never been taught that before, and I have a feeling that a lot of you were taught the same way that I'm going to show you right now. And I think it's easier than the way that I was taught. So, when the denominators are different, the first thing that you need to do is kind of like cross multiply. You multiply diagonally like that. What is 9 times 5?
45.
It's 45. So we're going to put a 45 up here in the top left corner. Make sure that you start with the top left and multiply to the bottom right first. It doesn't matter as much when you're adding, but when you're subtracting, you need to make sure you're doing it in the right order. And then you go from the top right to the bottom left. 2 times 10 is 20. And then you multiply the two denominators. 10 times 5 is 50. Therefore, when you add together 9/10 and 2/5, you add together 45 and 20, that gets you 65. The denominator stays a 50. Can 65 over 50 be reduced? Yes. What does it reduce to? 65 over 50 reduces to
13 over 10.
13 over 10, I think is right. 13 divided by 10.
I was never taught that way.
Number 6, the same thing. Different denominators, so I'm going to multiply top left to bottom right. 7 times 3 is 21. And then I'm going to multiply top right by bottom left. 2 times 8 is 16. And then we're going to multiply the two denominators. 8 times 3 is 24. Add 21 and 16 together. 21 plus 16 is 37, I believe. And then we have on the bottom 24. Does 37 over 24 reduce? No. It does not. You guys can finish up the last two on your own. But I'm going to move on to number 9. Denominators are the same again. What's different about it, though? You're subtracting. So number 9, 1/4 minus 3/4. Denominators are the same, therefore you just keep the denominator off of 4. And then you just subtract the numerators. 1 minus 3 is negative 2. Negative 2 over 4 reduces. What is negative 2 over 4? well, negative 1 over 2. Negative 1/2. The 4 would have to be on top in order for it to be 2. Negative 2 over 4 is negative 1 over 2. Number 13, denominator is at 13, so it's going to stay at 13. Stays at 13. You have 12 minus 8 is 4. 4/13 does not reduce. Finish up 11 and 12 by yourself. Number 13, denominators are different. We are going to use the same process that we used above when we were adding. So we start in the top left, we move to the bottom right. 1 times 6 is 6. Top right to bottom left, 4 times 5 is 20. And then we multiply the two denominators, which give us 24. 4 times 6 is 24. Make sure the numerators are subtracted. So you're going to take 6 minus 20. 6 minus 20 is negative 14 over 24. Negative 14 over 24 is equal to negative 7 over 12. So you have negative 7/12. Number 14, top left to bottom right, 7 times 5 is 35. Top right to bottom left is 18. Multiply the two denominators. 9 times 5 is 45. Make sure you subtract the numerators. 35 minus 18 is 17. Then you have a 45 in the denominator. And then you try to reduce 17 over 45. I believe 17 over 45 does not reduce. Yeah, so we're going to leave it just like that. Finish up the last two, and then we're going to move on to applying this to rational expressions that have polynomials in them. The good stuff. Handed you all a piece of paper that says adding and subtracting rational expressions number 1. The front page has 10 problems on it. Now, a lot of my second hour today was like, oh my gosh, okay, can we just get started? And I'm like, no. You think that you know exactly what to do, but there's lots of little things that come up all the way through this. So please hang on. I'm sorry that you're going to be bored sometimes today. What I think I'm going to do is do a couple of the ones where where they have the same denominator. We'll do those together, and then I'll do some that don't have the same denominator together, and then I'm probably going to give you some time to work, or maybe, I don't know. We'll play it by ear and see what happens. But let's start with number 1. It says 8v squared u squared is on the bottom. The denominators are both 8v squared u squared. So when the denominators are the same, what happens to the denominator in the answer? Stays the same. All right, so you just write down the denominator. The denominator is going to be 8v squared u squared. What do you do to the numerators? Well, you're going to subtract them. And the reason you're subtracting them is that there's a subtract sign right there. But let me take you back to the beginning of this unit a long time ago. The easy stuff. Remember when we had something like this? If you had 2x squared plus 5x minus 3, and you had to subtract, say, 3x squared minus 4x plus 5 from it. Do you remember this?
Yeah, you plus.
What did you do to that minus sign in the middle?
Oh, you made it a plus.
Changed it to a plus.
And then you took the 4 and made it.
And then everything after it had to change signs. So the 3x squared became negative 3x squared. The minus 4x becomes a plus 4x. And then the plus 5 becomes a minus 5. Do you remember doing that? Yeah, do the same thing here. So you're going to change that minus sign to a plus sign. And then everything after it switches signs. But the problem is this, it's everything in the numerator only. Do not touch the denominator. So that means that that u is going to become a negative u, and then the minus 6v will become a plus 6v. And now you just add the numerators, yes.
Do we do that every time?
Every time there's a minus. Every time there is a minus, you change it to a plus, and then everything in the numerator only after it gets switched. Okay. All right, so do you guys see how you have a positive u and a negative u? If you were to add them together, they cancel right out. Make sense?
Yeah.
All right, you have a 5v that has to be added to a 6v. That's going to get you 11v. You have 11v. Now, are we done?
The negative one, too.
A negative?
Oh, wait, never mind.
Nope, no negative.
Nope.
But remember how you always check at the end. Remember on all those fractions that we were doing a minute ago on that fractions paper? They were all, we checked all the time to make sure they couldn't be reduced. Could or couldn't be reduced. Can this be reduced?
No.
Is there something, is there something alike in the numerator and the denominator? The v, yes. There's a v in the numerator and there's a v in the denominator that I can cancel out. So I'm going to get rid of that v in the numerator. I'm going to get rid of one of the v's in the denominator, so it's going to leave me with just a v. So my final answer is 11 over 8v u squared. Number 2. Check for same denominator? Yes, same denominator. Keep the denominator the same. So this is going to stay a 30m on the bottom. Danny, can you grab the phone for me, please? Thank you. Stay at 30m on the bottom. The numerators. We're adding so all you have to do is just add like terms. So we have a 5n and a 4n. They can be added together. What is a 5n and a 4n added together? A 9n. So we have a 9n, and then we have a 2m. Can we add an m to an n?
No.
No, they are not like terms. They have to be exactly alike in order to add them together. Now, my next question says, can I cancel out the m's? We have an m on the top and an m on the bottom. Can I cancel them out? This m right here and this m, be careful. It is not just 2m. It is 2m plus 9n. You cannot cancel them out because that plus sign right here screws it up. If that was a times sign, 9n times 2m, then we could do it. But that plus sign screws everything up. You may not do that. Now, we're going to get to this in a little bit, but if there happened to be an m somewhere in this 9n term, and in the 2m term, and in the 30m, if there was an m in every single one of those, then you could cancel them out. Is there an m in every single one of those terms? No, there's not. All right. And then in a little bit here, we're going to get into the habit of putting boxes around all 3 sections of our answer, and if there is something that is alike to all 3 sections, then you're going to cancel it out. Okay, let's go on to number 3. Same denominator? Yes, keep it the same. So we are going to keep a 6a cubed in the denominator. There's a minus sign in between the fractions, so change the minus sign to a plus sign. And then what do I change?
You change from that 5 to a negative 5.
Yeah, so the 5 is going to become a negative 5, negative 5a, I should say. And the plus 4b is going to be a minus 4b. Now we just collect like terms. We have a 1a and a minus 5a. That's negative 4a. And we have a 2b minus 4b. That's negative 2b. We're not done with this yet.
Weren't we negative?
Oh, wait, never mind. Now what we need to do is recognize that in the numerator right now, it's factorable. There is something that is alike to both terms in the numerator. What is alike? What can I factor out of a negative 4a and a minus 2b? You can factor out a negative 2. You can factor the 2. Let's try to get rid of the negative that's in there too. So I'm going to take a negative 2 out. And when I take a negative 2 out, I will be left with 2a. What happens to the minus 2b? It's going to be plus b. And I'm going to cross that off. And the reason I did that was because I saw that it could be factored, and I wanted to factor it because I knew once it's in factored form, there might be something that I can cancel out with all three terms. So, do you see this negative 2 and this 6? What can I do with negative 2 over 6?
You can factor out.
You could reduce it. What does negative 2 over 6 reduce to? Negative 1/3. So we have a negative 1 on the top. We have a 3 on the bottom. We have a 2a plus b in the numerator. In the denominator we have an a cubed. And that's it. Isn't this great, you guys?
This is a lot of work.
Yeah, adding and subtracting is the most difficult of all of them. You know, most time consuming, lots of little tricks here and there. Number 4, what's the common denominator going to be? 18 xy. I'm going to change the minus sign to a plus sign, and everything after it switches signs. So that 6 is going to become a negative 6, and the positive y will become a negative y. And now you just collect like terms on the top. We have an x here and a negative 6x. If you have an x minus 6x, what do you get? Negative 5x. Very nice. We have a positive y and a negative y. They cancel out. That's nice. What can I do now? The x's cancel out. Why can I cancel out an x on the top with an x on the bottom?
There's no adding.
We're multiplying. There's no plus or minus signs separating them. Very nice. So you're going to end up with negative 5 over 18 y. Okay, I said I was only going to talk about a couple of them together that had the same denominator, but I'm looking at number 5 and realizing I need to talk to you guys about number 5 too. The first thing I want you to do is, this hasn't come up yet, but in this case it does, so I'm going to talk about it. The bottoms of these things, first of all, they're the same denominator, right? Same denominator. They're also factorable. 6a squared plus 30a, factorable. Factor it first. If it can be factored, factor it. You guys love factoring, so you may as well just practice it more. What does a 6a squared plus 30a have in common? 4. 6a. They both have a 6a, so I'm going to take a 6a out. Great. I'm going to take a 6a out. If I divide a 6a out of 6a squared, you're left with a. If I divide a 6a out of 30a, you're left with 5. I'm going to cross that out. So we have 6a times a plus 5. The second one, it's going to factor exactly the same way. I'm not going to factor it again. That would be silly. So now I'm just going to leave the denominator as 6a times a plus 5. And I'm going to tell you in just a minute why I'm doing that. Just bear with me for right now. The numerators, we're adding, denominators are the same, so you just collect like terms. Add 4a and 1a. What's 4a plus 1a? 5a. Add together negative 5 and a negative 1, you get negative 6. Can you factor the numerator? Is there anything alike to the two terms in the numerator that you can factor out? There's nothing. They don't both have a's. They're not both divisible by the same number, so we can leave it as 5a minus 6. So, if it was factorable, there's always that chance that if you could factor the numerator, one of the factors would cancel out with one of the factors in the denominator. That didn't happen in this case, but sometimes it will. Okay? Number 6. Denominators are the same. Are they factorable?
Yes. Plus
Yes. They're both the same thing and they're factorable. What can I factor out of a 9x cubed plus 27x squared?
9x.
You can factor out a 9x squared. If you factor out a 9x squared out of 9x cubed, you're left with an x. If you factor out a 9x squared from 27x squared, you are left with a 3. And the reason we did that was because there's a chance that when I combine the numerators, we'll have like factors on the top and the bottom. All right, so the denominator is going to stay 9x squared times x plus 3. We have a minus sign in between the fractions, so I change the minus sign to a plus sign, and then everything in the numerator afterwards changes signs. So what happens to our x? It's negative. What happens to our plus 6? Becomes a minus 6. And now collect like terms. So we have a 5x plus a negative x, that gives me 4x. And then you have a negative 4 minus 6, that's negative 10. Is 4x minus 10 factorable? Yes. What can I factor out of it? A 2. So I'm going to take a 2 out. And if I take a 2 out, it leaves me with 2x minus 5. Is there anything alike in the numerator and the denominator that I can cancel out? Is there?
Nope.
No, there's not. So my final answer here is 2 times 2x minus 5 over 9x squared times x plus 3. Now some of you might be wondering, so do we multiply through? Do we go back to what it was before it was factored? If you want to, I don't care. Either answer is acceptable. I will be looking for both answers, on your test. I'm sorry, I will be looking for one answer or the other, not both. One or the other. Okay. I think I am not going to talk about 7 and 8. In fact, I am recording right now, so I think what I want to do is go on to a couple that have different denominators. And then you guys can go back and work on 7 and 8 by yourself. Let's go on to 9 and 10. Have different denominators. All right, so I want to talk about 10 first. Why am I talking about 10 first? It's add, it's not subtract, yeah. Different denominators. Let's go back to what we talked about when we were reviewing fractions before we started this stuff. Top left to bottom right, remember you multiply those two. What is 8 times 3v squared? 24v squared. And then multiply top right by bottom left. 4 times 7v minus 6. Remember, you have to distribute. You need to make sure that you distribute that 4 to both the 7v and to the minus 6.
So it's
28v minus 24. Yep. And then we're going to multiply the two denominators. And I'm going to put the 3v squared out front. You can put it in the back if you want to, but I'm going to put it right up front. So we have 3v squared times 7v minus 6. And now we just have to add. We just have to collect like terms if we can in the top, which we can't, by the way. We have a 24v squared plus 28v minus 24 in the numerator. Are you okay with that? You're just adding polynomials together. Denominator is going to be 3v squared times 7v minus 6. All right, let's stop and think about this. Is there anything in the numerator that I can factor out?
4.
Yes, you can factor out a 4. So you could go through, you could factor out a 4. If you factor out a 4 though, you're going to be left with 6v squared plus 7v minus 6. Is that going to cancel out with anything in the denominator?
No.
No. So leave your answer. You're done. You can't do anything else to this. You could experiment a little bit to see if maybe you could come up with something, but I think at this point, we're as good as we're going to get. Yes?
Wait, did we ever do like terms from the numerator and the denominator?
Yep.
Then can't we take out the never mind?
Can't we take out the never mind? Wait, let me show you something. The numerator, you don't have to do this, but watch what happens. If I do happen to factor out a 4 out of the numerator, I would end up with 4 parentheses 6v squared plus 7v minus 6. Do you see how maybe you might think that those 7v minus 6's could cancel out? Why can they not cancel out?
Because of the plus.
Yes. In front of this 7v minus 6, we have a 6v squared. That 6v squared right here is being added on, so these things are not alike. They are not like terms. So your final answer in this case, just so we're on the same page here, 24, for some reason I decided to change my v's to an m, 24v squared plus 28v minus 24, all divided by 3v squared times 7v minus 6.
What's it with you trying to change the letters all of a sudden?
Number 9. I'm going to run through one more with you. Number 9. Different denominators, right?
Yes.
All right, let's cross multiply. So we're going to do 7x times, actually, you know what? Let me back up. I need to change that minus to a plus. Change the x to a negative. Change the negative 2 to a positive 2. And now I'm going to cross multiply. Leave it in factored form. Don't actually multiply these through. So I'm going to leave it as 7x times 20x plus 16. Multiply this way, top right to bottom left. That gets you 2x times negative x plus 2. Multiply the denominators. You have 2x times 20x plus 16. And now we need to add them together. So, this is going to get ugly. I'm going to come down here because I'm running out of room. We have a 7x times 20x plus 16 plus 2x times negative x plus 2 divided by 2x times 20x plus 16. Now, remember a little bit ago I said when you end up with these long situations here, put a big box around the 3 individual parts of our answer. And when I say parts, I mean there's 2 in the top separated by that plus sign. Now, if there is something in each one of those 3 parts that can be reduced, then reduce it. Is there something that shows up in every single one of these parts?
X.
There's an X, yes. Get rid of it. it showed up in all three parts. If it only showed up in two of them, you couldn't do this. But it shows up in all three, so I can reduce it. Anything else? I have a 2 here, and I have a 2 here. But I don't have a 2 over here. I have a 7 in front. I have a 20x plus 16 and a 20x plus 16. Can I cancel those out?
No, because
No.
you don't have the third one.
It's not in the third part. So I think that's all that you can do. So your answer would be 7 times 20x plus 16 plus 2 times negative x plus 2 divided by 2 times 20x plus 16. So this certainly could be cleaned up. You could distribute a 7 in if you wanted to. In fact, I might make parts like this extra credit on the test. Like if you can polish it off as far as it could possibly be polished off, maybe I'll give you extra credit. But I would say what we have right now is an acceptable answer. This answer right here would get you full credit.
What do you mean by polish it off?
So what I mean by that, if I can keep talking here, if you were to distribute 7 times 20x, you would get 140x, and then multiply 7 times 16. What's 7 times 16? Can someone do the math for me quickly?
112.
112. Okay. Plus 112. And then you do 2 times negative x is negative 2x. And then you do 2 times a positive 2, which is a positive 4. And then in the denominator, you can multiply 2 to 20x, getting you 40x. And then 2 times 16, which is 32. And then you can keep going with this because now you have 140x that can be combined with a negative 2x, which would really get you 138x. And then we have 112 plus 4, which is 116. And then you divide that by 40x plus 32. But I bet we could keep going again. And the reason we can keep going now is because each one of these terms is divisible by some number. 2 would work for sure. See what I'm going? See what I'm doing? So you could factor out a like term on the top, factor out a like term on the bottom, and then cancel, reduce that way. You could certainly keep going with that. Do you see what I mean?
That's a lot of work.
It is a lot of work. That's why it would be extra credit. Are you okay with that?